these steps when we get to chapter 3 as well. So you're going to put all these numbers in. So the way you're going to put numbers into your calculator is you'll go to stat, this number right here. Sorry, this button. That's the button that we're going to be using most often in this class because it's statistics. Surprise, surprise. So we'll go to stat, and under edit, you'll go to the first one, which is edit. And then here's my L1. That's my first list, basically. So if you want to put your numbers in, which I wouldn't for 65 of them because that's too much, I'd go up to L1 and I'll clear it out and then hit enter, and then everything's gone. So that's what I'll do before I start putting my numbers in. You don't want to hit the delete button when you have your L1 highlighted because otherwise it's going to get rid of the entire L1 and you won't have that list anymore. If you do that, just let me know, I can get it back for you. Or if you're borrowing it and somebody else deleted their L1, that's fine, I can get it back for you. It's not that hard. It's just a couple extra steps to get it back. So once you do that, you can put your numbers in. If I just do the first 10, I'm not going to do all 65 of them. If I just do the first 10 and type those in, so my graph is going to look completely different than the one up there because I'm only using some of the numbers. But just to show you what you would do. So if I just put in the first 10 numbers, if you notice here, if I highlight the 0.53, the last one that I typed in, this number here, along the bottom it says L1 and then in parentheses it has 10 in parentheses. That means it's the 10th item in your first list. That's a way you can double check to make sure you put them all in. If you know you've got 25 of them and you highlight the bottom one and it has a 24 here, that means you only put 24 numbers in and you're missing one. So that's how you can tell you've put them all in. So I've got all 10 of them in, and now to graph it, let me come down here to these steps. All right, so I put everything into my L1 by going to stat edit, and then I'm going to do second y equals. So above my y equals button, way up here at the top, right below the screen, mine's in yellow, but yours might be a different color, like blue or green or something. It says stat plot. So we're going to be going to a plot for statistics. So we'll do second y equals to get to stat plot. I'm going to turn mine on. When you do these, this is plot 1. Plot 2, you want to be off. Plot 3, you want to be off. So if they're not, come down here and just select all plots off. If you have more than one on, it might give you an error because it's hard for them to graph more than one plot on the same set of axes sometimes. But if I go to plot 1 after I've got everything else turned off, I'm going to make sure this is highlighted, blinking on, so I'm going to hit enter, turn it on, and then down here I'm going to go over to the histogram, this one here, top right corner. Just make sure that's blinking and then select enter. And then my X list is L1, my frequency is 1. So I put all of my data values in L1, my first list, and then the frequency will always be 1 for these ones. And once you have that established, to actually graph it, you're going to push zoom 9, and that's going to be the case whenever we graph any of these. Most of these we're going to go through, not this one, not that one. This one, and this one, and this one we're going to talk about as well. So anytime you graph from this screen, if you just do zoom 9, this is a histogram of just those first 10. So that's what it would kind of look like. We have kind of, that'll give you a rough idea of what it looks like. But like I said, what you get in your TI-84 is not necessarily what it's going to look like on the screen because it doesn't have the same class width. So don't rely too heavily on this one because they don't use the same procedures. Okay. And then we also have this one down here called an open-ended class. That's just if you don't want to keep going. So here they've got ages and they break it up. Here the class width is 10. You take the difference between consecutive lower class limits, 15 minus 5, you get 10. They do it. So then once they get to this point, they don't want to have to keep going, 85, 95, 105, and on like that. Once they get to that point, they think, well, that's old enough, so they just say 85 and older, rather than having a cap on that last one. I don't know if I really would have done in this case, because that's the highest one. So I don't know if I agree with judgment. But so you can do that either for the bottom one here, or you can have up here, you can have the top one be, 4 years old and younger. You can have an open-ended one at the beginning too. So if that's the case, you can still have an open-ended class in your frequency distribution, but when you try to graph it, you just can't do a histogram for it because you don't have, for this bar, you wouldn't have a place where it really technically ends. It would just keep going on forever. So for these type, you can't really do a histogram for, but you do see sometimes a frequency distribution where it's open-ended like that. Okay, and then we've got discrete data. So if we don't have something that's continuous, if it doesn't make sense for us to have decimals or fractions, and all we're looking at is whole numbers, the histogram is going to be a little bit different here. We've got this example where we look at the number of children an adult woman has for a sample of 1,000 corresponding frequency. So they did the histogram over here. Here, the 0 to 1 block, that's just going to be this frequency. So this actual number, this category they put down here is like the lower limit. So instead of having really a lower class limit, this is just going to be category. And then this is going to be the frequency. So the category is going to be the number on the left. So here's the answer of 0. The bar following it is its corresponding frequency. Here's the answer of 1. The bar following it is its corresponding frequency. Here's the answer of 2. The bar following that will be 2's frequency. All right, so that's histograms. You won't have to build them. You might have to do a multiple choice select which one is correct. Or they might ask you questions like for this one, which one is the most common answer. So in that case, 0 is the tallest one, so 0 would be the most common answer for that survey. They might ask you class width, not necessarily for this one, but like for up here, they might ask you class width. Okay, so now we're going to get on to the shape of a distribution. So based on what the histogram is going to look like, we can have different names that we can assign to the shape of the distribution. So we've got a bunch of different options up here. The first one we're going to have, the first statement is that it's symmetric. So if it's symmetric, its right half is a mirror image of its left half. So you know what symmetrical means. And then they make the statement that it's not usually going to be perfect with the symmetry, but we want something that's just kind of close enough. So if we look down here at this example here, I mean, it's not perfectly symmetric, but it's pretty close. I mean, these two are not the same height, but that's okay. I mean, they're close enough. So this one we're going to say that it's just approximately symmetric, and that's all we need is just for it to be approximate. Okay, so I guess technically this one is symmetric as well. It's what they call the uniform distribution. Yeah, we'll get to that one in a minute. But that one's symmetric as well. These two on the bottom are not symmetric, so if you take this and flip it over, it's not symmetric. So you've clearly got a peak over here on this side and then like a tail over here on this side. So we've got a peak and a tail with these ones. And so if it's not symmetric, we're going to say that it's skewed. And then we want to say what direction it's skewed. And when I took this class, I always got confused about which direction it was. When you're looking to see what direction it's skewed, you're looking for where the tail is and not the peak. So if you look here, your peak is to the right, but it's not going to be skewed to the right. Your tail is to the left. So whenever you're doing these, look for where your tail is. That's the direction that it's skewed. So here it says histogram with a long right-hand tail. Since the tail is to the right, we'll say that it's going to be skewed to the right. And then on the other hand, if we have one where the tail is on the left-hand side, we'll say that it's going to be